The recordings are not uploaded. I'll try to upload the recordings by tomorrow. And today we're going to start with January 2020. I'll still solve this entire paper from the start to the end. Wait 1 minute. Okay, yeah, as I was saying, that means after this, I have already gave you guys two files, right? The January 21 and your January 22. These two papers are going to be your homework, which you guys have to submit by Wednesday morning. So not Wednesday morning, but Tuesday at night. Okay, I mean by Tuesday you guys have to submit this paper. And on Wednesday, you guys can watch the recordings for this. And if you have any problems, we can do a problem solving. But base thing is that you guys have to sit for your mocks again. So mocks from Unit 1, mostly on this week, Thursday. Right, I think for Imad and Fayad, we have our P1 mocks on this week, Wednesday. So other than that, P1 mock on Thursday again, you guys will have your Physics Unit 1 mocks. Okay, mock 1 was already done, I think. So it will be mock 2 on this week, Thursday. For Safia and Shanaz, I think for you guys, we didn't take any mock 1. So you guys will have to sit for the mock day and then again mock 2 on for other batch with this week, Thursday. Okay, so you guys have two mocks to sit from Unit 1, mock 1 and mock 2. Is that fine for everyone?
Ma'am, when is mock one?
Mock 1 will be on Wednesday at 8 p.m. Sorry, 11 p.m. Bangladesh time. And again, similarly for Mock 2, it's going to be on 11 p.m. Bangladesh time. For Imad and Fayad, you guys will have to sit for Mock 2 only. Imad, I think you also missed Physics Mock 1, right? You didn't start for the Mock 1 in the last week.
Yeah, teacher.
In that case, you have to sit for Physics Mock 1, Pure Maths Mock 1. A lot of exams you have to do within this week. Okay, I will still give you a different timing for maths P1 if I can give you, or mock 1 if I can give you in the mornings. Okay, are you available somewhere in the morning on Wednesday before your school?
Yeah, yeah, I will be.
Okay, in that case you will sit for
Uh,
the yeah. When are you available?
teacher, Wednesday, I'm only
Yeah,
available before 11 Qatar time.
before 11 Qatar time. Sure. Then you can sit for the exam at 9 a.m. on Wednesday for the mock 1 physics. Okay.
Yeah, okay.
Okay, then we will start with your January 2020. I'll try to solve this entire paper. Now, for the first one, it says, what is the SI base unit of kg meter square second power cube? I can clearly understand this is basically maybe something like this, right? Kg meters per second multiplied with um, meters divided by square, right? Something over here, this should be the case. Kg meter per, okay, 1 minute. I cannot just simplify it, but I can simplify this. This is kg meter per second square, right? Force and, force is actually mass and acceleration. This is momentum. This is just kg meters per second. Power is what? Power is energy divided by time. Now, energy could be anything. Energy could be um, kinetic energy. It could be kinetic energy. Kinetic energy is kg meters per second whole square divided by second. Sorry, 1 minute. Yeah, okay. This, if I simplify, kg meter square slash second square divided by second, and if I further simplify it, it does become that kg meter square slash second power cube. Then this is the same format. That means option C is your correct answer. And for work done is just energy. So energy is kg meter square second square, right? So this is not the same answer. So option C is your correct answer over here. I hope question 1 was clear for everyone. Moving on to question 2. Which of the following statements describe the gravitational field strength acting on a body at a point? This is gravitational field strength, not acceleration. Field strength means force per unit mass, right? This is your, wait, sorry, 1 minute. Everyone is still joining the class. Yeah. This is force per unit mass. So for this one, it says gravitational force per unit length. Wrong. This is gravitational force per unit mass, right? This is your thing. Force per unit mass. That is option B is your correct answer. For gravitational field strength, also, if you remember, the unit was Newton per kg. So this is obviously option B is your correct answer, and not any other options. And then we're done with question 2 as well. Let's quickly move on to 3. This is about vectors. The diagram shows how the velocity of an object before and after a force was applied. The magnitude of the velocity did not change. I mean, the magnitude never changed, but the direction changed. And we need to find out that, which following arrow represents the direction of the change in velocity. Okay. Previously, it was traveling vertically, and after that, it was slightly tilted to the right. So if I just, create a parallelogram, I can clearly understand that this is the diagonal along which your force is going to be vertical upward, slightly tilted, slightly tilted. In that case, this was your origin from where you started. Oh, wait 1 minute. It says that the diagram shows the direction of a velocity before and after a force was applied. That means from there the force was applied, right? Before it was vertically, like traveling in the vertical plane, and after that a force was applied somewhere. After that, cause it tried to move in this direction, right? So you have to understand that this is not the origin actually over here. In this case, this is the mistake. That origin was actually over here. 1 minute, I'll delete this. Right. The origin was actually, it was originally traveling in this direction, and because a force was maybe acted on at this point, I do not know exactly the direction, but a force was acting on this point. Because of that force, the direction of this vertical plane was slightly tilted to this direction. Right. If this is the case, then you have to understand that I have to maybe extend this over here to create a right angle triangle. If this is the case, then always I've stated that our forces should be or develop or the directions of your vector quantities should be always moving away from the center, not towards the center. That's why I have to extend this before direction of your velocities to this part, so that it kind of moves away from the origin. Now it is moving away from the origin, and you can understand in order to create a triangle, this will be traveling in this direction, right? Which is your option. The closest that it matches with is the option B, right? Slightly shifted to the left hand side is slightly shifted to the below the horizontal plane, right? This was the horizontal plane. This is slightly shifted to the horizontal plane. So this is your velocity before, this is your velocity final, and this is your resultant velocity or the direction of your force because of which the direction of your velocity changed. Only the direction, but the magnitude didn't change. That means that's why the size of the arrow is same because the magnitude is same. Only the direction of the arrow is changed. So option B is your correct answer. This is how you're supposed to identify this. Any problem from this part?
No, miss.
No, no.
Okay, we are done with question 3 then. For question 4, it says that a ball mass M projected vertically upward, a resistance F acts on the ball at all times. Which of the following equation gives would apply to the ball as it is traveling upward? It is traveling upward, and um, it is just traveling upward, right? But it never stated something that it was maybe accelerating or something. But we did took the acceleration, sorry, a resistance a part of our calculation. If this is of mkg, that means obviously weight is going to be mg. As it was traveling upward, that means friction over here is going to be in the downward direction because motion was upward. And in the upward direction, you have what you will have a no, which of the following equations would apply to the ball as it is traveling upwards? Right. At all times. Over here, it never mentioned anything about if upthrust is acting or not. Right. So I think this is the only two forces that are acting. Vertical upward and air resistance F acts onto the ball at all times. Which of the following equations would apply to the ball as it is traveling upward? Since it is traveling upward, then yes, Aisha, you can ask.
Miss, what direction would the air resistance be like acting on the ball? Would it be acting downwards because the ball is moving? Sorry, would it
Up.
be acting downwards if the ball is moving upwards?
Yeah, the ball is moving upward. That's why the air resistance is acting in the downward direction, right?
Oh, sorry. Sorry, Miss, I still didn't see that yet. Sorry.
No problem. Now, I mean, this is the case, but over here they never mentioned anything about upthrust, right? Since they didn't mention anything about upthrust, that means I'm only going to say that, resultant force equals to mass acceleration. And yeah, this is it. In that case, in this situation, you only have mg plus f, right? So you just can write just only weight plus friction, and that is equals to ma. Right? Other than this, we don't have any informations here, right? Because if you understand that equals to 0 and 0, that would indicate that object must be moving with velocity, constant velocity, right? Where acceleration is 0. But they never mention anything, because if we have only two forces in the downward direction and no forces in the upward direction, that obviously indirectly means that there is not object is not balanced over here, right? Object is moving with acceleration. That's why option A and B will never be the correct answer. And this one would be the equation if the object was falling. Then weight was acting in the downward direction, air resistance will be acting in the upward direction, which will make the value for F negative. Sorry, which will make the value for F negative. So this equation we could have used when the object was falling downward, maybe. So we can write falling downward. But as we are working with traveling upward, for traveling upward, these are the only forces acting. We don't have any reference about upthrust, only weight and force was acting. So we can say option D is your correct answer, right? Resultant force equals to mass acceleration, and he broke down the resultant forces mg and f because these are the only forces acting in this direction or acting in this situation. Is this clear? Any problem from question 4?
Yeah. No, Miss.
Okay, then after this, if you move on to question 5, two objects P and Q are at the same position at time t equals to 0 seconds. The diagram shows how the velocity v varies with time t seconds after each second, after each object. Okay, there are two different, objects on the same journey. Now it says that for part object P, it will move with constant velocity for first 2 seconds, and then again reverts its direction and move with the same constant velocity with the negative velocity, because obviously it has reversed its direction. And for object Q, it will accelerate, it will accelerate initially at a higher rate and then again move with a constant velocity for the rest of the journey. So for object P, it was moving with constant velocity, and object Q, it was moving with acceleration with a decreasing gradient, we can say, right? So A with decreasing rate. And this was just moving with constant velocity. Now over here, which of the following statement describes the position of P and Q at t equals to 4 seconds? Okay, I can understand that over here for t equals to 4 seconds, the, wait 1 minute, describe the positions of P and Q at t equals to 4 seconds. It says that P and Q are both at initial point. You have to understand that they have given you the velocities, not the, initial, displacements over here. Right, yeah. I mean, over here, they will never be in the initial positions. Their velocities are maybe reversing, but it doesn't mean that, they will go back to their original position. Maybe they have changed the direction, but not to the initial position they will return. That is not a stated important fact. Then P and Q are at the same distance from the initial position. P and Q could not be at the same distance from the initial position, because we can clearly understand that, area under the two graphs are not equal. Over here, this is going to be what? This is going to be 2 and 2, that's 4 units. And if I do the, if I do your approximation, I would be receiving 4 multiplied with half, that's just 2. Right, so the area under the graph over here is not same. If the area under the graph is not same for both of them, that means obviously they are not at the same distance from the initial position. So B is also not correct. P is further from the initial position than Q. P is further from the initial position than Q, and Q is further from the initial position than P. 1 minute. Over here, you have to understand that the area traveled over here is 2. 2 into 1 is 2, and this is also 2. But the total displacement, if you want to find out, is going to be 2 plus minus 2 because the direction got reversed for this one. So it will be 0 meter. Actually, P returns to the original distance, right? P returns to the original position. That's why you get 0 meter after the entire journey. But if you're talking about your particle Q, for particle Q, if you do the approximation, right, for the approximation, what do we have? 4, and this is 0.5. So area under the graph here is 4, 0.5. That leaves you with 2. So displacement here is 2 meters. So Q would be 2 meters further away from the initial position, whereas P would return to the initial position after 4 seconds. That means obviously Q is further away from the initial position than P. Option D is your correct answer over here. You just have to find out the area under the graph and compare that with each other to find out the answer. Is this clear?
Miss,
Any? Yes, Tanisha?
but the area under the graph, if you consider 0.5 and 4, isn't it like a trapezium? But you took the
No,
whole rectangular area.
no, that's not a trapezium. This is the original shape, right? But the problem is for the original shape, I cannot use any regular formula because this is like a slopey diagram. This is a curve. That's why I considered using this type of shape. This
But
is a.
what about the small triangular part?
I am assuming that, this area is equals to this area using the approximation method. This area, which was originally a part of your graph, is equivalent to this area, which was originally not a part of your graph, right?
Yes,
Is this clear? Is this clear?
yes, miss.
Okay, any more questions for the approximation method? Over here, I cannot count the squares because they have not drawn the squares over here. So I have to use the approximation method of turning this irregular shape into regular shape, which is the closest I can turn this into a rectangle. Any problems so far from this part? Question 5.
No, miss.
No, miss.
Okay, if there is no problem, then we'll quickly move on to question 6. For question 6, again, it says that a ball is traveling horizontally at a speed of 7 meters per second, and the ball hits a vertical wall and rebounds with its initial velocity as this much, 1 minute. A ball traveling horizontally at this is the initial velocity, and it hits a vertical wall and rebounds with its initial path. When the direction got reversed, that's what they're saying, and this is the final velocity. The ball has an acceleration of 300 while is in contact with the wall. Which of the following expression gives the time of the contact between the ball and the wall? Okay, mass was not given, right? Yeah, it's not needed also. I mean, this is what the actual case is, right? They're trying to find out the value for your time. Over here, this is your wall. The ball would go and hit the wall with a velocity of 7. So u is given as 7. Then again return back with a velocity of 5. This is 5. And then it was while it was in contact with the wall, the acceleration was a equals to 300. Right. So understand that acceleration was also again in this direction. Acceleration was also in this direction. This was 300. So I'm considering that, direction towards left is positive. If direction towards left, I'm considering that direction towards left is positive, then right will be automatically negative. But, I don't actually have to calculate. Over here, I have to find out the equation, like which one is going to be the final answer here. For this, I can see that let's take direction towards right as positive. If this is positive, then this is negative and this is negative because both acceleration and final velocity was to the left and we're taking directions to the right as positive. It's going to be t equals to v minus u divided by a, and that is minus 5 minus 7 divided by minus 30. Right, basically, what was your hint over here? The hint was that all of these orientations, they are only going to end up giving you one positive value for time. Time can never be negative, right? So this one would give you so this one would also give you a positive value for time. But problem is that there you are considering the initial velocity to be positive, but the final velocity to be positive, but acceleration was negative. where it was clearly stated in the diagram that acceleration and final velocity were in the same direction. So if you're taking v as positive, you should also be positive, right? And in that case, u in that case would be negative because u was traveling in the opposite direction. So this is completely wrong. And then again, this one will give you a minus value. So where there you got a negative time, that's why it's not a correct answer. This one would also give you a minus value. So this is also not a correct answer. Only option A is your correct answer. A only gives you a correct value for positive time, and again the same, like correct orientation for the minus signs. Final velocity, acceleration, both were negative because they are both traveling in the same direction. Is this clear? Any problem from question 6?
No.
No, miss.
Okay, then after this, if we move, the trolley X and Y of masses m and 3m respectively are traveling at the same speed towards each other. The trolleys collide and move off together. Move off together means after the collision, they're going to get connected to each other and would travel with the same combined velocity. Let's use the final velocity as s because v is already used here. This is x and y. And which of the following statement is correct? The force of x on y during the collision is greater than the force on y in x. This is completely wrong, right? Because during collision, Newton's third law plays role. And according to Newton's third law, they both exert equal and opposite forces on each other. They cannot exert more or less force on each other. Then the force of x on y during the collision is less than force. This is again wrong. Newton's third law understanding. We know that this is not correct. The speed of x after the collision is greater than v. They are saying that, the final velocity after the collision is going to be greater than this value. Mm, 1 minute. They say the speed of x after collision is greater than initial velocity. We have to understand that in this case, what happens for x, if you talk about for particle x, it was originally traveling towards left, so traveling towards right with a velocity of v. During the collision, a force of f newtons acts in the opposite direction to that of your motion, right? So this force would actually decrease your velocity. Like the final velocity you will get to after the collision will always be decreased than this initial velocity because your force was acting as a resistive force. If I was talking about y, then for y, actually, it was traveling in this direction, right? It was traveling to the right, it was traveling to the left, and there also it got opposite force. This resultant forces on each particles were always opposite to the direction of the velocities they were traveling. So after the collision, both of their velocities are supposed to get decreased because the resultant force is in the opposite direction of velocity. If the resultant forces are opposite direction of velocity, so velocity will always decrease. That means S is supposed to be less than V, right? Final velocities of all the particles are going to be less than the initial velocities. So this is wrong. And in that case, speed of x after collision is less than V. That is your correct answer, right? We understood that from this diagram, that because of the collision, they exert equal and opposite forces on each other. Now, these forces on the individual objects acts as a resultant force, and resultant force is against the motion. That means whatever the final velocity they will end up with, that final velocity will always be less than the initial velocity. Is this clear? Any problem from this question 7?
Miss.
Okay, then after this, if we move, it says, yes, Aisha, you can ask.
Sorry, miss, but could you explain a little bit more why B could not be the answer?
B.
Yes, miss.
Because in B, they're saying that the force on of x on y during collision is less than the force on y on x. I mean, why would this one will provide more force on y than it will provide on x? According to Newton's third law, during collision, they always exert equal and opposite forces on each other, right? And again, there's no reason for exerting more forces on each other. They have the same velocity, they have the same masses. So how can they, not obey the Newton's third law? During collision, always obey Newton's third law.
Miss, but Y has 3m as its mass and X only has m as its mass.
Yeah, that's, oh, sorry, yeah, no, that's it. Masses are not a problem over here, right? Momentum obviously have to be conserved in this case, but during the collision, they follow the basics of your Newton's third law. Like if I'm going to, like, doesn't matter regardless of your mass, if I'm going to provide a force of F newtons on you, you will also provide the same amount of force on me in the back, in the opposite direction, right? Maybe the force that I'm providing on Y, that might not accelerate Y at a faster rate because the mass is big, right? But that is the individual cases that you're talking about, right? That is this individual case you're talking about. That over here, this force might not be able to, like, decelerate V or decrease V. Like this force will act on X because this one has a smaller mass. But according to Newton's third law, when they're going to be in contact with each other for the collision, they will always exert equal and opposite forces on each other, right? Regardless of their masses. Because in Newton's third law, if you remember the 5 points, masses was never a point, right? The 5 points were the forces must act in the same line, in opposite direction, of same type, in on different objects, in and of equal magnitude, right? Those were the formulas, or those were the 5 criteria for Newton's third law. It doesn't involve anything about masses. Newton's second law involves about masses, right?
Okay, thank you so much, Miss.
Okay. Any more questions from question 7?
No.
Then if we move on to your question 8, a motor has an efficiency of 68% and is used to raise a load of 350 newton through a height of this much. Which of the following expression gives the energy supplied to the motor? Okay, the basic energy supplied to the motor. That means they're trying to find out the input energy here, right? So for the input energy, the formula is always efficiency equals to output minus, so divide by input multiplied with 100%. Since we already have 68, that means we know this is going to be what? 0.68%, right? So we get 0.68 multiplied with input. I mean, if I just make the input energy of the subject of this equation, we have output divided by 0.68. For output, we have what? mg, and this is 8. So we basically have gravitational potential energy. So we have 350 multiplied with 25 divided by 0.68, right? So which is your option D in that case. Sorry, 1 minute. Right, so this is your option D in that case, right? So this D is your final answer. This is, by the way, GPE I'm using as an energy, and this is just the efficiency multiplied by, divided by 100 percentage in decimals. This is it for question 8. I didn't explain anything over here much, actually, just rearranged the equation. Any problem from question 8?
No, miss.
Okay, then we're quickly moving on to question 9, which is about materials. It says that the length of steel wire is fixed at one end and the increasing force applied to the other end of the wire. The force extension graph of the wire is shown. There's 3 points, P, Q, R, right? Which row of the table identifies the point P, Q, R on the graph? I can understand that, like if I'm going to draw a straight line,
Miss, can I answer?
yeah, sure, 1 minute. Yes.
Uh, P is the yield point and Q is the uh, elastic limit and R is the limit of proportionality.
Can you explain?
Because up to R, this the extension graph obeys Hooke's law, and after that, when it reaches Q, it is after the Q point, it will deform plastically, extend plastically, and after the yield point, it will,
Stick limit?
yeah. Uh, I mean, up to Q, it will act like an elastic and go back to original shape. After that, P is the yield point. After that, it will deform plastically.
Yes. Over here, the graph was only a straight line up to point R, indicating that object was only obeying Hooke's law till R, right? That means obviously this is your limit of proportionality. After point R, the graph, I mean, the shape of the graph is no longer a straight line. It starts to create a curve here for this section. As soon as it creates a curve, exactly after limit of proportionality, you always get your elastic limit. And after your elastic limit, you always get your yield point, right? At yield point, you get the, like, over here, your object will obviously deform plastically. If you remove the force, the object will never return to its original shape, right? So in that case, R is limit of proportionality, Q is elastic limit, and P is yield point. So option C is your correct answer here. Any problem from question 9 from anyone?
No, miss.
Okay, then thank you, Tanisha, for explaining this to us. Then moving on to question 10. For question 10, they say some students were shown a velocity time graph for the motion of an object falling through a liquid. This is the velocity time graph. I can clearly understand what is happening. This is object is accelerating but at a decreasing rate, because initially it has a high steep acceleration, then low steep acceleration, right? Gradient decreases. So decreasing rate, decreasing rate. Now, the students suggest possible explanations for the decreasing gradient of the graph. The explanation could be a reason for the gradient of the graph decreasing. Like, which one could be the gradient information over here? Understand that object was still accelerating, but the rate of the acceleration would decrease. That means what? If your acceleration's rate is decreasing, that means certainly force over here was decreasing, because according to the equation F equals to ma, mass is constant. If A is decreasing, means obviously force is decreasing. And what force is that going to act over here? The object was falling through a liquid. Inside a liquid, these are the forces acting. Wait 1 minute. Sorry. Inside a liquid, these are the forces going to act. mg in the downward direction, and in the upward direction, you have a drag force, right? So I'll just write D over here. Yeah, 1 minute. Not only just drag force, you also have upthrust and then again drag force, right? So problem is that upthrust and weight, they are fixed, right? For any particular material, upthrust depends on what? Upthrust, the formula is rho Vg, right? The amount of volume displaced by the material is going to be same. Density for the fluid is same. Gravitational field strength is same, right? So they're all equal. So they will never change. Then again, mg, this is the weight. This will also not change. That means in this situation, in order to make the object accelerate at a lower rate, this is how the situation is. Rf equals to ma. Then over here you have drag plus u plus, sorry, minus. Drag plus u minus mg equals to ma. Over here, these things are constant, right? They cannot change. So in order to decrease this force, this must increase, right? Drag over here have to increase because object was falling downward, right? That means, if object was actually falling downward, then you have to consider it in this way, that mg is positive, then drag and upthrust would be negative. So if that is the case, this portion is a constant, right? They are not changing. That means if A is decreasing, the resistive force which can increase is drag, right? So resistive force increase, acceleration decreases. That's why the rate of your acceleration is decreasing. That's what is shown in the graph. So drag force increases. Option A is your correct answer. Gravitational force can never increase. Temperature of the liquid doesn't actually increase. As you go inside the water layer, as you go more deeper and deeper inside the water, the temperature might decrease, but they will never increase, right? So that is also not the case. And the upthrust on the object decreases? No, as I've already stated, that if the object is entirely submerged into the water body, that means the volume cannot change, right? I mean, only thing that can change over here is that the volume of the water that is displaced by the object that could have changed, but now the entire object is already inside water, is already entirely submerged inside water, so it has already displaced all the volume of water it could displace. So volume is constant. So volume is constant, gravitational field strength and density of the fluid is constant, so upthrust can never change. So upthrust never change. Option A is your only answer here. Any problem from question 10?
No, miss.
No.
Okay, so if this is the case for Afti and Mohammed, you guys actually missed section A. You guys have to watch the recording for section A again. Okay, we are going to quickly move on to question from sections B now. Our class today is going to be a little lengthy because I want to finish this paper. Okay, now again, this is actually a repeated question you can consider, not just a repeated question, this is from your unit 3 background also. Because in this question, they're going to describe that how can you measure the gravitational acceleration for free fall using experimental methods. Okay, for example, they are saying that a student carried out an experiment to measure the acceleration of gravitational free fall. This is actually your core practical 01 from unit 3. Actually, unit three is actually taken from unit one and unit two, right? So from unit three, they will never ask you to describe the method, but in unit one, they will ask you to describe the experiment. Like if you were in the lab, how would you use the equipments to take the measurements, and how would you take the measurements or use the measurements to plot a graph or to get to the final result, right? So in the descriptions for your core practicals will be asked in your unit one. So this is your core practical one actually. I mean, even though we didn't explain core practical one, but we will be able to understand the overall working through for this question. For example, in this question, they're saying that the ball bearing was released from a position A. This is the position A, and at time t, for the ball bearing to fall a distance L was measured, okay, and was repeated for decreasing values of L. I mean, now they are like decreasing the values for L, and again they're going to check that how much time it takes for the object to travel the new lengths over time, new lengths for every time of the journey. Now you have to understand that over here it was released, right? Release means that initial velocity over here is zero. So if initial velocity here is zero, time can be measured using a timer. And then again, distance is measured using maybe a meter ruler, right? Final velocity, I do not have the idea what will be the final velocity before hitting the ground. That is not given. That means now if I want to find out the value of your acceleration using UTS, this one will give you the value of your S, right? So which equation do you think I should use over here to find out the value of your acceleration? This is certainly related to kinematics that we can understand. And from
S is equals to ut plus t square.
okay, Aisha, do you have any other options?
No, miss, I was going to say that one.
Right, we are going to use this one. Other than this, we cannot use any other equation. Some people might think that we have ut and distance. We can also use this equation, right? But we cannot use this equation because this over here for this equation, the main assumption was that the object must move with constant velocity, right? Constant velocity. And what is my main motive of this experiment? To find out acceleration. At constant velocity, acceleration would be zero. So we cannot use this equation into any part of my calculation for this experiment. Okay. But over here, since we have UTS, so obviously we can use the equation S equals to UT plus half AT square. But from there again, UT is going to be zero, right? Because U is zero, so UT becomes out to be zero. So you have S equals to half AT square. And then further, we can write this as 2SAT squared plus 0. Now, this is exactly in the format of y is equals to mx plus c, which means that if I can plot a graph of 2s divided by t squared, this will be a graph of straight line passing through the origin, and the graph's gradient is going to give me the value for your uh, acceleration. Right, this is your rise, so I run, and this is your rise. Run is delta x, rise is delta y. So in that case, gradient here is going to be delta y over delta x. That is just acceleration, right? Is the idea clear for everyone? What we're supposed to do here? In this case, they've already mentioned, that they are going to take multiple readings for length, for which they're going to measure multiple readings for time also, that the timer will measure. So from this information, so we got to the idea that 2s plus 80 square plus 0 is exactly in the format of y is equals to mx plus c. So if I can, use this data to correctly plot a graph for 2s on t square, then the gradient of this graph will be able to give me the value for your gravitational free fall acceleration. Is this clear? Any problems so far?
Yes.
Just one. Can you guys just wait for a minute, please? Sorry. Okay, sorry, as I was explaining. So this is how the basic idea should build up. Now this is again a repetitive question. You will see that this exact question might have came in your maybe in 2023 paper also. I exactly do not remember the session, but this exact question came again in your 2023. So I just have to write down the description. This is a 5 mark description. That means this is not a star mark question. They will not obviously judge or criticize on your grammars and arrangement of the points, but this is still a 5 mark descriptive question. It says that suggest the measurements obtained. It suggests how the measurements are obtained. That means you have to state that, using meter ruler to find out the distance, and then again for timer, what you should use. Over here, obviously, I could have used stopwatch to measure the time, but it would be better if I could use maybe, data logger, right? Because data logger would give me a much more accurate time without human reaction time, right? So that's going to increase my accuracy of the entire results. So I can use data logger for time and meter ruler for or meter rule for your distance. Other than this, actually, I was not measuring anything else, right? Initial velocity was zero. There was nothing to measure from here. I was only measuring this timer and time and distance, right? So these are the two equipments we have to use. One thing we can say again that in order to make sure that my meter rule was vertical, I can use a set square, right, just to increase the accuracy for my distance calculation again to make my experiment as fair as possible. And then after this, I'll take 5 readings for distance. With that, I will also get 5 readings for time, and then plot the graph of 2s over t square, and that will give me the gradient as acceleration, right? So over here, this is what I'm going to write, that explain how the measurements obtained can be used to determine. Oh no, you don't actually have to write down the equipments here, that what are the equipments you're supposed to use. It says that how can you use the measurements obtained, like they have obtained the measurements somehow. How are you going to use the data over here to find out the acceleration using graphical method? So you're basically going to write that over here, since they are measuring distance, as L, and time from timer where u is 0, so we have to do the derivation here. So that half at square can be written as 2s a t square plus c, which is in the same format of y is equals to mx plus c. Sorry. Right, which is the same format as y is equals to mx plus c. So plotting our graph of 2s on t square will be a straight line passing through the origin where gradient is equals to a, right? Or a, we can say gradient is equals to g, right? Gravitational acceleration is g. So gradient is equals to g. This is how your answer is supposed to be. And obviously, you have to label the graph with the axis and then again plot the graph of a straight line passing through the origin and this area, and this gradient calculation. So this is it for your question 11. Any problem from question 11 from anyone?
No, miss.
1 minute. Okay, then if we move on to your question 12. For question 12, it says that Stokes' law can be used to determine the magnitude of the viscous drag for small spherical objects moving through a fluid. There are actually few assumptions for anything to be considered as under the Stokes' law. The assumptions are that obviously the object has to be small. That means they must have a small radius. R must be very small. Object is spherical, must move with a smaller velocity, and also should be
Laminar
laminar,
flow.
right? Also should be inside a laminar flow, right? So we can write any of this, that smaller velocity or laminar flow. Both could be accepted over here. That object must move with smaller velocity or inside a laminar flow, right? Carl and Tanisha, you guys are correct. It could be in laminar flow or it might be moving with small velocity or slow moving sphere or something. So we can write slow moving sphere also. Any one of them will be accepted. Okay. Now, after this, for part B, a sphere falls through water at a constant velocity of this. So V is given, V term is given. Assess where Stokes' law can be applied to the following object or not. You should include calculations in your answer. Diameter is given as 6. That means obviously radius is going to be 3 into 10 power minus 3 meters. And then mass of the still is given. Upthrust is given. Viscosity of the air is given. Of the water is given, sorry. Okay, now from this case, I can understand that it's falling through water with constant velocity, right? If it is falling through water with constant velocity, it means obviously upthrust and weight is equals to each other, right? um Sorry, not just upthrust and weight, drag plus upthrust is equals to weight, right? Because if it's falling, that means weight is in the downward direction, and in the upward direction upthrust and drag is acting, and the combination of upward force is equals to downward force. as object was moving with constant acceleration where a constant speed where acceleration is 0. So we can write that, okay, resultant force 0, that means drag plus object was falling downward, that means weight minus upthrust minus drag is equals to 0. Over here, if I just make drag the subject, or you should include calculations, we have to assess if Stokes law can be applied over here, right? We will try to find out the value for actually, drag. So if drag, if I want to calculate, then we have weight minus upthrust. Weight is just mg, which is 9.1 10 power minus 4 multiplied with 9.81, that is your mg, minus upthrust over here is already given. Upthrust on ball bearing, that was directly given as 1.1 10 to the power of minus 3, which is 1.1 10 power minus 3. If you calculate this, then you are going to get 9.1 10 power minus 4, 9.81 minus 1.1 10 power minus 3. That, 1 minute, that gives you 7 point, 9, 7.8271 into 10 to the power of minus 3. So you get 7.83 10 power minus 3 Newton. Okay, so you get the value for your drag as this much. If this is the value for your drag, we just have to find out the value for your velocity, like v term over here. So if this is the value for your drag, then according to this velocity, what would be your value for your drag force? Okay, I mean, this is the value for your drag that you get if you are using the forces distribution case. But if you're going to use a value for your velocity, then how much value for your drag is you're supposed to get? So FD in that case is going to be 6 pi r eta v term. So 6 pi r was given as 3 into 10 power minus 3. Eta was viscosity was given as 9.8. So 8.9 10 to the power 4. V term was given as 0.5, I think. Yeah, 0.5. If we now calculate this one, 6 pi 3 10 power minus 3, 8.9 10 power minus 4, and then 0.5. That gives you 2.52 into 10 power minus 5 Newton, right? If I write this into decimals, if you have to understand, it is actually 0.00783 Newton, and this is 0.0000252 Newton approximately. You can clearly understand that if you use the force distribution, you have almost 0.01 Newton force, and over here this is actually 0.00002 Newton force, which is very small, right? I mean, if the object was actually obeying Stokes' law, then the drag force acting on the object must be this much. But in real life, according to the force distribution, the drag force acting was 0.00783 Newton, right? Which is obviously far more bigger than the drag force that was supposed to act on this situation, right? So that means we can see that, comparison is not equal, or you can say that object does not obey Hooke's law because the drag force acting on the object is greater than the drag force it was about to, it should have acted on the object according to the terminal velocity. So Stokes' law can, oh wait, 1 minute. If drag force is this much, we can, yeah, in that case, what? If you're using a very large value for your drag force, then velocity would also be high, right? So in that case, we cannot use drag force over here. Or sorry, we cannot use Stokes' law into this situation, right? That would be your final conclusion. Is this clear?
Yes, miss.
Right, you could have done it in this way, or you could have also, completed this in the other option. Other option would be that you could have calculated the value for your drag, value for your velocity, the v term over here. V term in that case was 0.00783 divided by 6 pi 3 into 10 power minus 3 and 8.9 into 10 power minus 4. And that will give you the velocity as 0.007 0.00783 6 pi 3 into 10 power minus 3 and 8.9 into 10 power minus 4. and that leaves you with 155.6 meters per second, right? In this time also you can explain that, the velocity according to this is far more big, and obviously at a large velocity like this, Stokes law can never be applied onto any situation. So depends on you in which method you want to write. If you want to write about the forces method, then you can say that uh, the forces, the Fd that acts on the particle is bigger should act on it. So Stokes' law does not apply. I wrote the answer in terms of forces. So this is just an extra work. You can write this also. If you're talking about velocity, then don't need to write about the forces. Any problem from this question 12? Any confusion?
No, miss.
Okay. If there is no problem, then we'll quickly move on to your question 13. For this question 13, I think we did this in our worksheets already a lot. It says that a book of length L of W is positioned on a shelf as shown, and this is the center of gravity. What is meant by the center of gravity? This is a repeated question about definitions, right? A point at which weight appears to act for an object, right? So okay. Then after this, there are contact forces at two positions where the book touches the shelf, and the book is moved to a distance x to the right as shown, and the magnitude of the contact force R varies with x. Okay. Then again, sketch on the axis below the variation of R as x variation of R with x between 0 and half. You should mark the positions for the maximum value for R onto this axis. Okay. Now, hmm, L by 2, L by 4, and then x, right? What is this L by 2? Oh, in that case, they are referring to, you have to understand that in this case, if this was the total length, right, they are saying that L by 4 and then again L by 2. And this is your value for L over here is just 0, right? If this is exactly at 0, at this point, what happens, right? When L is exactly 0, that means on the shelf, right? This was the shelf. Sorry. This is how the shelf was, right? Sorry, 1 minute. This is how the shelf was. I will draw 4 diagrams for it. So when the book was entirely inside the shelf, okay, if the book was entirely inside the shelf, right, in that case, or not exactly inside the shelf, exactly at the start, what you can what you can see over here, that this is only in contact with one part of the shelf, right? That means this is somewhat like this. Right, this is somewhat like this. Over here, what happens? Half of the weight will act on this part, right? If the total weight was W newtons, half of the weight will act on this part, and the other half of the weight will actually act on this part, right? Because as you can see, this time the book was in contact to two parts of your bookshelf, right? And this is obviously a reaction force acting on this part again. Now, exactly when the length was 0, that means the book was entirely inside the shelf. At length was 0, it will be half of weight, right? So this is your, if I'm going to consider this is your W Newton, this is going to be half of your W Newton, W by 2. This is the initial point, right? Exactly when length was 0, the book was entirely inside the shelf. This is the weight that should be equals to your reaction force, right? Reaction force is equals to W by 2. Okay, and then again after this, what happens if I'm going to push it a little bit further more? It was originally here. If I'm going to push it a little bit further more, that means now this is at this region, right? At this region means what? 25% of the book is outside the shelf and 75% of the book is inside the shelf. 1 minute. This time also it looks like, it's 25% outside the shelf. And yeah, I mean, over here, I exactly do not know what is x, right? When x is just the distance that is outside the self. Okay, so this is the another scenario that could be possible. Over here, x is entirely equals to L, like, or x is entirely equals to 0. And this time, x is going to be like, 25% is outside and 75% is inside. That means over here, this scenario is for x is L by 4, right? Because it's still 75% of the length is still inside the shelf. At this point, what happens? Over here, um, now if you consider that, your center of gravity was in the middle, right? So this point, there's obviously a weight at this point. There's also a weight at this point. But now you have to consider that what will happen to your W this time? You have to understand that obviously there is some extra force acting on this direction also, right? Because 25% of the book is outside the shelf. That means over here, it's not 50-50% distribution. This time, this will get like, 3/4 of the weight, 3/4 of the weight, and this one actually gets 1/4 of the weight. So exactly at this contact, the reaction force is equals to 3/4 of the weight. This is your second scenario when your bookshelf is 25% outside the shelf. Okay, this is your second scenario. In second scenario, what happens when x is L over 2, W is going to become 3 by 4, 3 by 4 W. So I'm going to consider this as 3 by 4th W. So that means over here, I'm going to get another point at this point. And then again for your third scenario, if I just copy this and write down the third scenario where I'm going to balance this entire book now. Onto a space like this. This time it is 50% outside the bookshelf and 50% inside the bookshelf. In this case, what happens? This is your x, right? This x means what? This is your x. In this case, it means that over here, your x is half. Half means length over 2. And in this case, the total weight downward is balanced with the total reaction force. So your R becomes W entirely. So this will be somewhere over here, right? So you're going to connect three points. It kind of creates slightly curved. This is not entirely a straight line. This is slightly a curved line like this. Is this clear? This is your scenario 1, this is your scenario 2, and this is your scenario 3. Any problem from these 3 scenarios to shape this graph?
No.
Okay, then we are done with your part B also. Now it says that explain why the book will not remain on the shelf if x is greater than L by 2. This is talking about the fourth scenario, right? In the fourth scenario, what will happen? If the book is more than 25% outside the shelf, right? If this is the case, then what will happen over here? Actually, in this case, this time x is 3 by 4 length, right? If this is x is 3 by 4 length, that means over here, You're not all weight is acting. You have to understand that center of gravity at this time is already outside the shelf, right? If center of gravity is outside the shelf, this is only going to be able to balance 1 by 4th of the weight with the reaction force, right? Main idea is that when x is greater than L by 2, that means 75% of the book is outside the shelf. If 75% is outside the shelf, that means center of gravity at this point is already outside the shelf. And if center of gravity is outside the shelf, that means obviously there is no net moment in the clockwise direction. Like you have to understand that at this point, weight always acts from the center of gravity, right? So this time weight acts in this direction. This is your, what? This is your what? Net moment in the anti-clockwise direction. You have your total moment acting in the anti-clockwise direction, but there is no moment in this direction, right? We do not have any net moment in the clockwise direction. So the total momentum over here is no longer balanced. We do not have any net moment in the clockwise direction to balance the net moment of the anti-clockwise direction. Center of gravity is away, is now outside the shelf. So obviously the book will no longer remain on the shelf. It will just fall off the shelf. It will just fall from the shelf. This is a 2-mark question. So this is what you're going to write. That center of gravity was exactly at L over 2. Center of gravity was at x equals to L over 2. So when x is greater than L over 2, is outside the shelf, and if it is outside the shelf, so there is no um so like entire weight acts as a anti-clockwise moment. Anti-clockwise moment, and there will be no counter force, or yeah, there will be no counter force to, or yeah, there will be no counter force to create a net clockwise moment. Okay, so this is your answer for your question 13C. Is there any problem from this question 13C? Okay, if there is no problem, then we'll quickly move on to your question 14. Okay, question 14 is a star mark question. Right, for this star mark question, they're saying that when concrete is placed under stress, cracks may form. Scientists are investigating ways to prevent cracks. Yes, Aisha, you can ask.
Sorry, miss. And in that response, you said the entire weight will act as an anti-clockwise movement. I thought it'll tip over like in a clockwise direction.
Oh, sorry, this is clockwise direction. Yeah, sorry, made a mistake. This is a clockwise direction. In that case, there is no net anti-clockwise moment to balance it, right? So sorry, this is going to be anti-clockwise, and this is going to be your anti-clockwise moment, right? So we can write that this is your anti-clockwise, right? So there is no force, counter force to create an anti-clockwise moment to balance this. Yeah. Okay. Then after this, if we now move over here, scientists are investigating ways to prevent cracks from spreading through the concrete. One way to do this by adding very small capsule containing glue to the concrete mix. As a crack spreads through the concrete, some capsules break and releasing the glue, which fills the crack as shown. Like over here, they're saying that this is a crack. If the crack can reach up to this bubble, The bubble contains glue. That means when this crack reach up to the bubble will break. This glue will be released into the crack, and eventually the glue will now fill up the crack, right? So it will prevent the crack from moving further. This is one of the precautions that the scientists can do in order to prevent the cracking of concrete blocks. But other than that, two samples of concrete of identical size were placed under stress, and sample A is considered of concrete only. Like sample A doesn't have that glue bubbles in that, but sample B consists of concrete with capsules containing glue. Right? This is your sample B, and sample A is without the bubbles. And now they're saying that the stress strain graphs for the samples up to the maximum stress before the fractures are seen. The dotted line is for the only concrete, and the solid line is for the capsules containing the glue. We can clearly understand that over here, up to very small values, right? That means, sorry, 1 minute. Concrete, I mean, this is actually for your sample A, and this is for your sample B. I can clearly understand that the maximum stress taken by sample A is very small compared to the maximum stress that could be taken by sample B. That means obviously you're adding capsules, glue capsules into the concrete block must have increased the total maximum stress endured by the blocks, right? Because this is clearly bigger than this value. After that, up to very small values, after very small stress, their properties are quite similar. As you can see that after very small values of stress, the graphs are entirely parallel to each other, are overlapping with each other. So for very small stress values, they don't have that much difference in properties. And then again, particle A doesn't actually go for a nagging or anything. The particle A is kind of like a brittle hair, right? It will directly go or obey Hooke's law, and at the maximum point, it will directly just crack. But for object B or sample B, it has a lot of plastic deformation. Plastic deformation actually increases the energy absorbed, right? So we can see that for sample B, the energy absorbed by the concrete with capsule is greater than the energy absorbed by the sample without the capsule, glue capsule. And yeah, this is it actually. These are the things we're going to talk about. That there's no change in the properties for sample A and B for very small stress strain values. And then the area under the graph for sample B is greater than the area under the graph for sample A. For stress strain graph, the area under the graph always indicates the energy absorbed. That means for sample A, for a larger area under the graph indicates that sample A was able to absorb a large amount of energy before breaking, whereas sample A could only absorb a small amount of energy before breaking, and we can complete and compare that using the area under the graph. Other than that, we can also say that this is very after at very high values of stress, sample B becomes more steeper than sample A. Sample E is more steep than sample A. If this is more steep, that means obviously sample A will have more stiffer material, or sample B is a material with higher Young modulus compared to sample B, so sample A. And then again, maximum stress is greater for sample B than for sample A, right? As we can see from the graphing. These are the properties that I'm going to talk about. In this case, they're also asking you this. They explain how adding capsules containing glue changes the properties of the concrete. These are the things we're going to talk about. Again, this is a star mark question, actually, if you remember. This is a star mark question. That means your writing pattern, your arrangement of point, everything over here will be marked. Okay. So you have to make sure that you're going to you're arranging these things in a much more organized way. So the first thing we're going to see that at very low stress strain values, there is no such change, or there is no much change in properties for both samples. In both samples. Then again, after this, we can talk about that, area under the graph for sample B is greater than sample A. So energy absorbed by the concrete with capsule, glue capsule, is greater than the plain concrete. We just have to compare. We don't have to say that, which one is better or not. We are just trying to find out the differences. Other than that, I'm not going to say that that's why sample B is far more better than sample A. We cannot say that. And then again, the graph is much more steeper. The graph for sample B is steeper than sample A, making,
Yes.
yes,
Miss, you wrote the graph for sample is steeper. It should be
okay,
sample view.
sample B is steeper than sample A, making concrete with blue capsules more stiffer and um, wait, more stiffer and has greater Young modulus. And then again after this, we can see that maximum stress endured before breaking is greater for sample B than for sample A. Is greater for sample B. Right, so for writing all these points, you will get the 6 marks for the star mark questions. Any problem from this question 14 from anyone?
No, miss.
Yeah.
Okay, 1 minute. Every is present, right? Yeah. I think Mahmoud is not in class, right? Shanaz is in class. Muhammad, Kal, Mafia. Yeah, Mahmoud is not in class. Okay. In that case, we'll move on to question 15 now. This is about projectile motions, actually. Now, in this case, it says that the ball falls through a vertical height of 0.6 meter before bouncing at point A on a ramp, as shown, and it's going to run bounce at 70 degrees and 70 degrees from the vertical plane. State the velocity of the ball immediately before the bounce is about 3 meters per second. Immediately before the bounce means that obviously in this case, they're only focusing on the like vertical part of the journey. Okay, for the vertical part of the journey, initial velocity was 0, acceleration is going to be 9.81, distance traveled is 0.6 meter, and we want to find out the final velocity. So we're basically using the equation u square plus 2as, everything under the square root. So you get 2, 9.81 and 0.6, everything under the square root. So if you want, then you can easily calculate this. 2, 9.81, 0.6, that leaves you with 3.43, which is approximately 3, right? So 3.43 meters per second. But then again, all the information given in this question, 0.60, 70, that was given as two significant figures. So I should also keep my answer as two significant figure, right? Not 0.43, I'll write this as 3.4, not as 3.43, I'll write this as 3.4 meters per second. And after this, now they're talking about the kinetic energy conserved on the ball bounces of the ram. And the ball bounces at an angle of 70 degrees to the vertical. One thing over here is if kinetic energy is conserved, that means, the velocity with which it's going to hit the ground is going to be seen, the velocity with which it's going to move up from the ground. Like this velocity and this velocity is equal, as they're saying that kinetic energy was conserved. So you have to find out the vertical and horizontal component. If you remember, this is how the initial velocity was looking like. This was the initial velocity. It was creating 70 degrees with the vertical plane. So it's this time, so the horizontal component will have the 3.4 meters per second. It will have the 3.4 sine 70 because it was not creating angle with the horizontal component, but with the vertical component, it will have 3.4 cos 70 degree because as it was creating angle with the horizontal vertical component. So you have 3.4 sine 70 and 3.4 cos 70, right? So this is your distribution of velocities. After this, if we move, then over here, point A is 0.8 meters vertically above the ground. Now they are saying that exactly by the point from where the object will rebound from the plank, from the ramp over here, that was 0.86 meters above the ground, and it was 1.23 meters away from the end of the ramp. And we need to deduce whether the ball um, will bounce a second time on the ramp or not. Okay. Now we have to understand that after it's going to hit, it's going to hit on the ground or it's going to hit on the ramp. If it's going to hit on the ramp or if it's going to hit outside the ramp, we probably basically have to find out the range for this projectile motion. Okay. Now we can understand that okay, if this is the object with which the object was thrown, then 1 minute. You have to understand that this is the initial velocity with which the object starts the journey. But problem is obviously the object cannot stick to this direction, right? The object will actually fall in this direction. No, then this is actually entirely in the horizontal plane, and that's not happening over here. 1 minute. Okay, 1 minute. I think Carl have some suggestion. Miss, we can use the S equals to UT to find the time taken for the horizontal use, and then with that you can find out. Sorry, then S equals to UT plus half UT squared to find the vertical if it is above the ground or not. Problem is that I exactly do not know that. I mean, I can understand that obviously this hypotenuse length I can calculate using the Pythagoras theorem, but problem over here is that I cannot understand the type of scenario it's going to create. If it's going to move in this pathway, that's fine. Okay, let's just try to stick to this diagram. Like if it is actually traveling in this pathway, then what is the range over here? I meant displacement vertical. Oh, we can use S equals to UT to find out the time taken for the horizontal. Okay, and then use that time to find out the vertical displacement. Okay. But still, we would need to identify, what is the pathway followed by this specific object, right? I mean, yeah, we cannot actually consider this as scenario 1. We have to consider this as your scenario 3 or something, right? You have to consider this will actually reach to a maximum height and then fall back to the ground, right? This is what something, the pathway that the object can follow. Right, this is how the roughly idea is going to be. Now over here, you have to consider that, up to this point, right, over here up to this point, the object is symmetrical and beyond this, the object is not symmetrical. According to my diagram, it kind of looks like, the range over here is going to be greater than the hypotenuse. If I want to find out the, length of the ramp, so distance on ramp, I can use that. Distance on ramp, I can calculate that using the Pythagoras theorem, which is going to be 0.86 square plus 1.23 square, everything under the square root. Then if I try to calculate this, 0.86 square, 1.23 square, which is 1.5 meters actually. Like you get the distance over here as 1.5 meters. 1.5001, which is approximately 1.5 meters. Okay. I have to identify that if our journey's range is greater than 1.5 or not. If it is greater than 1.5, then the object will move or land outside the ramp. And if it's less than 1.5, then it will actually fall on the ramp. Okay, so in that case, for that horizontal distance this time, one thing that Carl said in the text, that I can use the horizontal equation for here. But problem is I am not sure if it's going to fall on the ramp or not. I do not have the value for the range. Without the range, I cannot use the horizontal horizontal motion of the journey of the projectile motion. That is my limitations here, Carl. I hope you understood your mistake there, right? I tried to find out the range. If I can find out the range, then only I would be able to understand that if it's going to fall on the ramp or not. I do not have the value for the range. I cannot imagine that the range is going to be 1.5. Is that clear, Carl? Carl, are you in class? This 1.23 u sine. Sorry, 1 minute. I cannot see 1 point. What do you mean by u sine 0xt? Can you please turn on your mic? What do you mean by u sine 0xt? I don't understand. Oh, 0 into t. Oh, theta into t. Okay. Uh, theta into t. And what is the value for theta then? I mean, you still do not have the, but we don't have the value for time in that case, right? Again, I am considering that, displacement. Oh, you're considering that over here the range is 1.23. Yeah, you can consider that in that case. Using that, you can find out the value for your time, right? And then you can, yeah, I mean, over here you have one method available. Like I was focusing on this as a range, right? But you are focusing on this horizontal distance as a range. Like this could also be considered as a range. If you're considering that, okay, if this is your range, then you have when you're focusing on the horizontal motion of the journey. For the horizontal motion of the journey, we're using s equals to u sine 70 degrees multiplied with t, where you take t, the subject, will be 1.23. Then u was 3.4 sine 70. Yes, this was only 1.23 divided by 3.4 sine 70, and that gives you 0.4. Wait, oh, sorry, my calculator is in radian mode. Sorry. 1.23, then 3.4 with sine 70, and that gives you 0.39, like 384 as your approximate value. If you can use a better value for the velocity, that would give you 0.39, right? This is your time over here. Okay, now using this time, I got the value for the total value for this entire case. Okay, now if I want to find out the vertical displacement, so for the vertical displacement, we are focusing on the vertical motion of the journey. For the vertical motion of the journey, you have s equals to ut plus half at squared. This time you have 3.43 cos 70 multiplied with 0.39 plus half. This is a double motion scenario I can understand. So acceleration is going to be minus 9.81 and 0.39 whole square, right? So if you calculate this now, this turns out to give you a value of negative 0.28 meter. This negative 0.28 meter means what? This negative 0.28 meter means that actually even after traveling, and even if you consider the 1.23 meters as your range, even after this, the ball does not actually remain on the ramp. But if it was actually remaining on the ramp, then the journey was supposed to be like this, right? The journey was supposed to be like symmetrical journey as your scenario one. And according to your scenario one, the vertical displacement was supposed to be 0, but you're not getting the vertical displacement as supposed to be 0, right? You are getting, if it was on the ramp, right? This is how the journeys were supposed to be. 1 minute. If it was on the ramp, then this is how the journey was supposed to be, right? Maybe even if it was like with a range of 123, right? Still, it was supposed to be the vertical displacement was zero. We do not get the vertical displacement as zero. We got it as negative. That means over here, this is how the journey was supposed to be, and this is how the journey got actually traveled. It reached to a like this type of diagram. 1 minute. Sorry. And after this, it would fall like this. Okay, and I will remove these lines. So this is how the journey is. That means over here, if it was this, up to this, the journey was symmetrical, and after this is your extra 0.28 meter travel in the downward direction. That's why you have negative value over here. Is this clear? I cannot actually draw the diagram properly. 1 minute.
Peter, can we assume that the way it travels is like a semicircle?
It's like a semicircle. This is how the journey is supposed to be. For semicircle is not a scenario actually, right? That's the problem. Like semicircle is not a scenario for the projectile motions. And again, if it is a semicircle, how is it related to your projectile motions? I mean, using a semicircle, you cannot solve the idea. Right up to this, it was 0.86 meters above the ground, and it would travel like in this pattern. Arif, I didn't understand about your semicircle concept. Can you repeat again?
Like, when the ball bounces,
Hmm.
you have drawn the red line, not the dotted spot. Yeah, it shows the journey it travels. Right?
The journey
Like,
actually looks like a semicircle, right?
so, for example, if it was from point A to all the way to the end, and it was a semicircle, we could like use the
Symmetrical
distance
journey,
of the ramp we found earlier.
right? 0.1.5 meter,
Yeah, we could use
right?
that
But
1.5.
in that case, I was assuming that over here, I am considering that the vertical displacement is zero. But how am I sure that vertical displacement is going to be zero or not? Right. Problem is I'm not sure if the vertical displacement is going to be zero or not. Right. That was my problem. That's why I could not, assume that if the range was 1.5, if the range was entirely 1.5, then my vertical displacement would be zero. So that would be a problem because I'm not sure if the range is 1.5 or not. What other easy method that we could have used here is maybe we got that over here the distance on the range on the ramp is 1.5 meter, but maybe this is not needed over here. If I consider that maybe whatever the journey could be, like whichever pathway it was following, that's not a problem. If I want to find out over here, if it is actually following in this journey, right? I mean, I can understand this is not going to be a symmetrical journey. This is actually one of those journeys. If you remember, 1 minute, if I really remove this, if I remember this type of easy diagram, I will write it down. This type of journey they're talking about over here, this type of journey will occur, right? This was 0.8 meters, 86 meters above the ground. 1 minute. Okay, the easiest explanation that I can find for this type of question is this one. Okay, we have to understand that the extra distance it's traveling is 0.86 meters down the direction, right, for this type of journey. If it is traveling 0.86 meters down the direction, obviously you can use this information. Okay, the other types of method, or the second method that you can use in order to solve this maths. Oh, we don't have. 1 minute. This paper doesn't have any blank space actually. Okay, I'll just keep that method 1 over here for 15 C, I think it was 15C. This is 15C method 1. We could obviously use this one. The other method that we could have used is this one. Over here, I understand that in order to be in the ramp, the range over here is supposed to be 1.3 meters, right? But if I want to find out the range, I can understand that over here for the vertical displacement, if you find out, vertical displacement or vertical motion of the journey, I can understand that over here s equals to ut plus half at squared. We have the value for s as 0.86. U is going to be 3.4 cos 60, cos 70 time minus 4.905, because obviously A was 9.81, half multiplied with 9.81 ends up giving you 4.905 t squared. From there, I can rearrange the equation and write it as 4.905 t squared minus 3.4 cos 70 t minus 0.860. Right, I can understand that I have to use the formula method now. In physics, you can skip the middle term actually. That will not be a problem. So 4.905 minus 3.4 cos 70, and then again 0.86 minus 0.86. And that gives you 1 minute. 4.905 negative 3.4 cos 70 and 0.86. That gives you a value for time as 0.55. Okay, 553, and the other is negative. We're obviously going to not accept the negative value. If the value for your time is 0.55 seconds, now you can use it to find out the horizontal motion of the journey. For the horizontal motion of the journey, using this time, you can find out the value for your s, which is going to be 3.4 sine 70 multiplied with 0.55. That turns out to be 3.4 sine 70, 0.55, and that gives you 1.76 meter. Now you can also, from this diagram, you can understand that if the range for this journey is 1.76 meter, which is greater than the horizontal distance left on the ramp, that means obviously the ball will not bounce on the ramp. The ball will fall out of the ramp, right? So we can say that as horizontal, or we can say that as range, which is 1.76 meter, is greater than 1.23 meter. So ball does not bounce on ramp. Right, so you could use the first method, you could use the second method also. The first method actually, like kind of builds on assumptions. Like for the first method, you are already assuming that you are going to travel the range for 1.23 meter. If 1.23 meter is traveled, then you get a negative displacement. Right, this kind of as a mixed variation, like you're already assuming that the range is to 1.23. So it has an assumption in method 1. But if you're using this method 2, then you don't have any assumption. You're just using the diagram over here to understand that what will be the range. If range is equals to or less than 1.23, then object will land on the ramp. But if range is greater than 1.23, then object will not land on the ramp. It will bounce out of the ramp. Is this clear? Method 1 and method 2. Whatever you want to use, you can. Markscheme have provided a range of values for this question, but I think method 2 is much more established explanation. Method 1 is also correct. Any problem from this question 15?
Okay.
No.
Noted.
Okay, if there is no problem, then we'll quickly move on to question 16. Then for question 16, it says that popcorn kernels contain water. When heated, the water turns to steam and the kernel pops and moves upward. Okay, this is a scale of 1 centimeter. And the photograph shows above a popcorn kernel just before popping at the maximum height after popping. Okay, and at the maximum height after popping. The time between the two photographs is 83 milliseconds, which is obviously 83, 10 to the power of minus 3 seconds, right? Determine the maximum height after popping. I mean, I think you're supposed to take some measurements here from the diagram, right? Yeah. Okay. If they are taking, this as 1 centimeter, so you have to say that, how many of the centimeters can fit in over here. 1, 2, 3, almost 3, and then I guess in a very small distance, right? So we can say that 3 point maybe, or I should also take the measurements from the middle to middle. This is 1 centimeter, this is 2 centimeters, and this is 3 centimeters. Then this rest of the space is, I think, how much? Less than half centimeter. This is, let's consider this is 0.3. So you have 1 cm, another 1 cm, another 1 cm, and then this is your 0.3 cm. So you get the distance is 3.3 cm, right? So you get 3.3 cm. No more workings here. You just have to do this measurement from the diagram using the scale factor method. That is just it, nothing else.
Yeah, but then why is it 2 marks?
Determine them. I mean, I think over here you're using determinations over here, or can we calculate anything? No, initial velocity is 0, time is given. Maybe you can also calculate over here. I mean, from the scale diagram you can measure this, or you can also calculate this. S equals to ut plus half at square. Then ut is 0, so you get half. Then 9.81 time is 83, 10 power minus 3 square, right? So then how much do you get? Let's see, 0.5, 9.81, and 83, 10 power minus 3.
Miss,
Yes?
wouldn't the value for A be negative for upward direction?
I mean, over here, I'm just trying to find out the maximum height. Height is just a distance, right? It would be negative, but problem is the negative sign will not be as significant over here for my calculation.
Okay, miss.
Okay, so 1 minute. It would be negative, but that will not bother with my equations. I mean, that bother with my height. I mean, from there also I get actually 0.0337 meter. If I multiply this with 100, in order to convert this into centimeters, then I get 3.37 centimeter, which is approximately 3.4 centimeter. So to be honest, they're asking you to determine, right? So you can use the scale factor method or you can calculate also. Depends on you. You don't have to do both the methods. You can use either determination or calculation. I would choose for the calculation actually. But both of the methods are going to be accepted because scale factor is given over here. That means you have to use the scale factor specifically, right? When that's one of the methods available. That's why they gave you the scale factor. So you can use scale factor or the calculation, whatever is easier for you. Is this clear?
Yes, teacher.
Even if you want to, like, focus on the scale factor, for the scale factor you have to do this, like, measurement. That's why they're giving you 1 mark and 1 mark for the writing part, writing the correct answer. And again, you can do the calculations. For the calculations you get 1 mark and 1 mark for writing the correct answer in the given space. So it doesn't matter whichever method you do, you will get the 2 marks. Okay, then option A is done. Then if we move on to option B, calculate the initial speed of the popped popcorn kernel. We cannot use calculations because in the previous case, I assumed that the initial speed was 0, right? Now they are saying that calculate the initial. Oh, sorry, no. This is for the popped kernel, not the unpopped kernels. Okay, so they are saying that for the popped popcorn, what will be the initial speed? Okay. I can clearly understand that, like, over here, initial velocity I have to find out, but I mean, calculate the initial speed of the popped popcorn. Okay.
Means
Hmm.
you already calculated the height, right? And you have the time and acceleration as well.
Hmm. Oh, I mean, this is how we are actually going to follow, right? Because it was initially 3.4 meters above the ground, right? I mean, we're talking about the popped kernel, right? Popped kernel was originally 3.4 centimeters above the ground. So it will travel up and then again fall downward. Like, this is how the method is going to be. Pathway followed by the pop kernel is going to be. So over here, I can understand for this type of journey, displacement is always negative of that 3.34 centimeters. It will be minus 0.034 meters. Then acceleration, this is a double motion, so it's also going to be minus 9.81. Problem is we do not know the value for your time. Yeah, we do not know the value for your time, but
Oh, then what is 8 point something? Oh, it's not the time.
this is not the time for this scenario, right? It was the time for the previous scenario before the kernel was popped. It was for the unpopped kernel.
Oh,
Or
okay.
1 minute. The time between the two photographs is 83 milliseconds. No, they're also giving you this that 83 milliseconds.
I mean, miss, the
Mhm.
unpopped kernel was not moving or anything. So why would there be a time for anything?
Okay, in that case, I think they are using this method. Wait, yeah, the unpopped kernel was not moving. That was initial velocity. When this is the maximum height reached, right? That means after this, it is supposed to fall downwards. Sorry, I mean, it was already stated that, like, the popped after popping, the kernel reaches to the maximum height. If this is the maximum height, that means obviously from there it will certainly fall downward. So it was supposed to just fall downward from there. It
Then
was
should
supposed
we
to just
multiply it by 2, the height?
No, not the height. You just have to consider that if it takes 83 milliseconds to reach this 3.4 centimeters above, then the same time will be taken for the popped kernel to fall downward, right?
Right.
Then time is 83 milliseconds or 83 into 10 power minus 3 seconds. That means now I can easily find out the initial velocity, which is going to be u. Um, 1 minute. U and s minus half at square divided by t. Right? I basically used the equation s equals to ut minus half at square, but just made u the subject of the equation. So you have what we have, s is how much, 0.034 minus 0.59.81 negative, because in the it's not going to be negative actually here, because now this is only a single motion journey, so it's just going to be 9.81 positive. So 83 10 power minus 3 divided by time was again 83 10 power minus 3. So if you calculate this, you get 0.034 minus 0.59.8183. This is a square over here. Sorry.
Didn't you take S as negative?
No, we're not supposed to take SS negative over here because this is now a single motion journey. For single motion journey, we'd not consider the double motion. We'd not assign the vector quantities with plus or minus sign.
Okay, miss.
Right, so just 1 minute, 0.034 minus 0.59.81, 83, 10 power minus 3 square, then bracket, and 83 into 10 power minus 3. Oh, this is supposed to be positive, right? Because in the opposite case, when you change the direction, it was originally s equals to like half a t square, then it will be positive in this case. Wait 1 minute. No,
How is it positive? Isn't
in
it
the
formulas
opposite,
minus?
no, the formula was minus, but in this case, when it is actually falling downward from the maximum height, I'm not assigning this with plus and minus, but 1 minute. But A over here is actually, going to be negative because, if you consider this, even for this entire part, this was originally traveling in this way, right? For this original pathway, if you think this is a double motion journey, then for double motion journey, A would be negative, right? A is negative, but if you're talking about the displacement is not considered as negative because displacement here is just 3 centimeter, 3.4 centimeters falling downward. So displacement distance is going to be positive, but A is going to be negative. But this is also negative and this A is also negative. That's why you're going to end up getting a positive value. Okay, acceleration over here is going to be negative. Is this clear?
Yes, ma'am.
If it's 0.816, that means if you go back to your question, the only information that they have given was this 83 millisecond, right? That was in two significant figures. So we should also round up our answer as to close to two significant figures. I would round up this to eight, one significant figure also, but that will make the answer less accurate. So we just stick to 0.82 meters per second. Okay, then after this again, if we start with our part B, so far any confusion from part A1, A2?
Miss,
Yes.
can you explain again how this is a double motion journey?
Because this is your unpopped kernel, it moves up to the maximum height and then falls back to the ground, right? So this is a double motion journey,
Okay.
right? And then if you take half of the journey, this is falling downward. In the downward direction, you have your acceleration negative.
Right.
Okay, then
How many
if you
questions do we have left?
I think three more questions. We have 19 questions here. Okay, it won't take much time. Just bear with me. Sorry. In question B, it says that the average water content in a popped kernel is 14% of the total mass of the kernel. A kernel is heated until it pops. Steam is ejected downward, and the popped kernel moves upward with an initial velocity of 5. Now they are saying that the popped by the time this kernel pops, it will move with an initial velocity of 1.5. Calculate the speed with which steam is ejected. Total mass of the unpopped kernel was 0.11 gram. It was already stated that it contains 14% of the total mass of the kernel is your water content, right? The average water content in the pop kernel. The popcorn kernel is 14% of the total mass of the kernel. And the unpopped kernel is given as 0.11 gram. Okay. The kernel is heated until it pops, steam is ejected downward, and the popped kernel moves upward at an initial velocity of 1.5 meters per second. Calculate the speed with which the steam is ejected. Okay, I mean, this is about explosion theory, if you understand. initially the kernel and the water, they were in a combined position, right? For the initial, before collision or before explosion, if you talk about before explosion, mass of kernel plus mass of water, they are both with the initial velocity of zero. So basically, total momentum before collision is zero here. After it pops, it's going to look like this. It pops over here, and steam is kind of ejected in this direction. So then, how much is the mass of your steam? 14% of that 11 gram, right? So you get 0.1 gram. So 14 by 100 multiplied with 0.11. That means your mass of water is actually 0.14 with 0.11. That is 0.0154 gram. That means after the explosion, what happens? This moves in the upward direction, this moves in the opposite direction. This moves with a mass of how much? Like 0.11 minus 0.0154. Over here, this one has a mass of 0.0946 gram with a velocity of 1.5, and this one has a mass of 0.0154 with a velocity of v. We want to find out this velocity. So we're basically using total momentum before collision is equals to total momentum after collision here, right? So for total momentum before collision was 0, after collision is 0.0946, 1.5 minus 0.0154 V. So you get the value of your V as 0.0946, 1.5 divided by 0.0154. You just use the concept about your collision explosion theory. 0.946, 1.5 divided by 0.0154. That gives you 9.21 meters per second. Okay, 9.21 meters per second downward. So 9.21 meters per second. Is this clear? Any problem from this question 16b?
No.
Okay. Then if you move on to your question 17 quickly, then over here, this is about your, I think, force extension again, right? An elastic cord was fixed between the end of an air track and a glider. The glider was pulled to the right, giving the elastic cord an extension of delta x as shown. Okay, the glider was moved to the right, delta x is shown. The original length of the cord was this much, and this is the extension. The glider was released and is moved to the left. The glider was released and moved to the left. A light gauge was used to measure the maximum velocity of the glider. This was repeated for different values of extension. The student obtained the following results. I mean, exactly why would the glider move to the left? Because when you remove the force, obviously because of the elastic strain energy of the elastic cord, the glider is kind of pulled towards to the left, right? And with the velocity, the glider will move with the left. That is recorded using the light gauge. It was mentioned over here. That was recorded using a light gauge. Now, this is the graph that they obtain. It says that the principle of conservation of energy predicts that the graph should be a straight line passing through the origin. Now, for the range of values of delta x used, the elastic cord obeys Hooke's law. Like for the range of values of delta x that you used, for that range, it is obeying the Hooke's law over here. So how can you explain the prediction over here? For this prediction, in that case, I can see that this is what. There is a motion related to elastic stored energy, right? Even if I extrapolate this line, it is supposed to pass through the origin, right? Yeah, even if you extrapolate this line, as you can see, it's supposed to pass through the origin. That is one of the predictions or extrapolation. Other than that, they're giving you 4 marks for this. The principle of conservation of energy predicts that the graph should be a straight line. Okay, in that case, you can think about in this way, that over here, what type of energy is getting converted to the glider? When you remove the force, the elastic store energy, right? Elastic stored energy, sorry, 1 minute. Elastic potential energy or elastic stored energy is converted to elastic, kinetic energy, right? Because the elastic stored energy in the spring kind of stretches the spring or compresses the spring. Because of the compression of the elastic cord, the glider will move to the left. There is a motion on the, I mean, for this compression of the spring, it causes a motion on the glider, right? That means the glider will now have a kinetic energy. So we can say that over here, your like elastic stored energy is getting transferred to, or elastic potential energy is getting transferred to kinetic energy. We can say as the elastic cord compress, the elastic potential energy is transferred to kinetic energy for on glider. And if that's the case, like all the elastic potential energy is converted to kinetic energy, then we can write elastic potential energy is how much? Over here, in this case, force over extension is a triangle. So we can write this is half force extension equals to half mass V square, right? And from there, if I want to make half and half cancels out. So we have half delta x equals to mass V square. So mass V square doesn't give you anything. What you can understand is that, like over here, your, wait, sorry, 1 minute. Yeah, this is the case, force extension and mass V square. But I can, also break down force, right? In this kind of cases, the gradient for this graph gives you spring constant, right? So I can also write this that, F is equals to K delta X. If I just, insert this equation into this equation instead of F, now I can write K delta X whole square is equals to mass velocity square, where both mass and velocity, so mass and spring constant are a constant values, because mass of the glider never changes, and spring constant for this elastic cord will never change, right? So in that case, we can say that if K and M are constant, under that basis, we can say that extension is directly proportional to the change in velocity. I mean, obviously they both have square will cancel each other, so extension is directly proportional to your velocity. And like if they are obviously directly proportional to your velocity, that means obviously the graph should pass through the origin. So the graph should pass through the origin, right? You have to understand that at this stage, how did we reach up to this stage? Because my main assumption was that the graph was a triangle, right? When over here, the original shape of the graph was only up to this much. But if I extend this line, it is a triangle that passes through the origin. It's going to create a triangle over here. Sorry, is going to create a triangle over here, right? And my main assumption was that, it creates a triangle. The area of the triangle was half force into extension. So under that basis, we end up with the conclusion that yes, in that case, all of the extension will be directly proportional to the velocity of your glider. And if that can match, that means obviously the graph should be a straight line passing through the origin, and obeys Hooke's law, obviously. So yeah, this is how we can explain the prediction. That means the prediction was correct, right? The student, whatever the student predicted, or whatever this, what was that? No one the overall prediction is correct, we can say. So prediction is correct. Is this clear? Actually, we don't need to explain that if the prediction was correct or not. We just need to explain the prediction. We explain the prediction in this way. Any problem from question 17, part A? Afti, Imad, Shanaz, any problem?
No, teacher.
Okay, then if you move on to this part. Determine the stiffness K of the elastic cord if the mass of the glider is 30 gram. Now they have given you the value of your mass. Okay. Imad, do you want to say something?
No, teacher.
Okay. Now, if you want to find out the value of your K, 1 minute. Did they provided me anything with the velocities? Determine the stiffness K on the elastic cord, extension and maximum. Oh wait, maximum velocity is given, right? Maximum velocity is how much? The maximum velocity that you can receive is what, 4.4 I can see. Two four six eight five, yeah, 4.4 meters per second. Maximum velocity that I can get is 4.4 meters per second, and then again it's 0.5 extension. At 4.4 you get 0.5 extension. Okay, so if this is the case, then again determine the stiffness of the elastic cord. Mass of the glider is given. I can understand that over here the final equation that I was supposed to get was K mass v square by x square, right? So if mass is given is going to be 0.3, that was how much, 4.4 square divided by 0.5 square, yeah, meter and meters per second. You get 23.2 Newton actually. So 23.2 Newton. I think all the data was given in this is in one significant figure, and this is the only data that was given, right? All of these cases, 0.1, 0.6, that was in also one significant figure. All the data was given to one significant figure, one or two significant figures. So I think we should keep our answer as approximately 23 Newton, right? So we'll accept, like, no, we'll stick to 23 Newtons here. I mean, over here, this is the only equation we received from this part, right? From there, I just made K the subject of the equation, and that gives you the final answer. Is there any problem from part B, A2?
No, miss.
Yes, if the glider was moved to the right by a further of 0.5 more extension, then the graph will start to become a curve. Till your 0.5, it was a straight line. Like if you increase the distance further than that, the graph will start to create a curve. That means what? After this point, the graph will no longer obey Hooke's law, right? That means the limit of proportionality is exited, and the object no longer applies, or Hooke's law no longer applies to the curve or applies to the object elastic cord. This is your answer. The reason for the curve is that obviously limit of proportionality is exited, or the graph is no longer a straight line where force and where extension is directly proportional to force. That means obviously Hooke's law no longer applies to this elastic cord anymore when you have extended this beyond 0.5 meters. Yeah. Okay, then this is what we're going to say, that if the graph becomes a curve indicating force no longer, or for indicating force no longer proportional to extension. If it's not directly proportional, then limit of proportionality is exited, and Hooke's law, an object or elastic cord does not obey Hooke's law. Right, this is your answer then. Okay, so we're done with question 17. Last two more questions left. It will not take much time, seriously. Question 18 is not going to be that much big. I hope 17 is clear, right? Any problem from question 17? Safia, any question from your side? Safia, Aisha, Tanisha?
No, miss. No, miss.
Okay, then we are going to move on to question 18. Question 18 is I think, again, unit 3 type of question. A student carried out an experiment to determine the Young modulus of copper. She added the mass m to a free end of a sample of copper in the form of a long thin wire, and the corresponding extensions delta x were measured. She was repeated. This was repeated for increasing masses. Repeated question, right? This is what is the what is the meaning of the term Young modulus? This is the ratio of stress or stress to strain for a material, right? You can just write this one. Ratio, how much mark? 1 mark. Ratio of stress to strain for a material. After this, again, they're saying that the student repeated the measurements of the diameter of the wire at different positions and orientations of the wire. Orientation means that cross-sectional area of a wire looks like a circle. So I can take the diameter from this angle. I can take the diameter from this angle. I can also take the diameter from this angle, right? So from 3 different angles or 3 to 4 different angles, they took the value for the diameter calculation or measurement. Now determine the cross-sectional area of the sample of the wire used. I mean, if the diameter is this one, I have to find out the area, right? I have 4 samples. That means I have to use a mean value of the diameter. So mean value of diameter is going to be 0.23, 0.235, 0.23, 0.24 divided by 4. If you find out the mean, it's going to be 0.234 millimeter, which obviously have to be converted into meter, right? Because area is always in meter square. So this has to be multiplied with 10 to the power of 3. Yeah, 10 to the power of 3 meters, right? Because in 100 meter you get, say, in 1 meter you have 100 centimeters, in 1 centimeter it gives you 10 meter, right? 10 millimeters, yeah, 10 to the power of 3. And after this, now for the area, it's going to be pi r square, but r is half of d, right? Or r is twice of d. So you can write pi d by 2 whole square. So you basically have pi 0.234 10 to the power of minus 3 divided by 2, everything under the square, right? Now if you calculate this, you're going to get a value of 4.3 into 10 to the power of minus 8 meters square. You can just keep it like this: 4.3 10 to the power of minus 8 meters square. This is actually a unit 3 pattern question, that where you have to find out the mean and then use the formula for the area to calculate the area. This is a unit 3 type question. Okay, then after this, if we move on to your next part, where they're asking you that the student plotted a graph of mass gain extension. She measured the gradient and obtained a value of this, okay? And determine the Young modulus of the copper. The length of the copper is this much, okay? Mass again extension, the gradient is this much, kg per meter. And we have to find out the Young modulus, but length of the copper used is 3.5 meter. And extension was also not given, right? So 1 minute. Kg per meter, right? 195 kg per meter. From there, I can actually, what I can do is that kg, if I can multiply 9.81, it's going to be kg per meter, then meter per second square. So it's basically going to be kg per second square. That doesn't make any change, but kg per meter multiplied with meter second square, that gives you Newton per meter. Yeah, over here, using this gradient, if I'm going to multiply, 9.81, that will give me the unit as Newton per meter. Newton per meter was what? Force over length, right? So we get Force over length from this force over from this basically 195 multiplied with 9.81. Okay, and force over length is given. Then again, not exactly length. I mean force over extension actually, right? Because this was extension, so we get force over extension. And if we have force over extension, length is also given. If you remember the formula for your stress over strain, stress was force over area divided by extension over length. If you flip this, it would be force over area, length over extension, right? So we already got force over extension, right? Which is this multiplied with 9.81. We just have to find out length over area. Length of area can be easily calculated. So that means basically we have to understand that gradient of mass on delta x multiplied with 9.81 meters per second square. This gives you force over extension. Okay. And I mean, this is the value that I'm going to get. We get force over extension from here. And for Young modulus, we need force over extension multiplied with length over area. That will restore the value for your Young modulus. So from here, I just have to use f over delta x was how much? 195 multiplied with 9.81. Multiplying this with length was 3.5 and area was 4.8, 10 to the power of minus 8 meters square. Right. So this is just it. 195, 9.81 multiplied with 3.5 divided by 4.8, 10 to the power of minus 8. So you get 1.39, 10 to the power of 11. 1 minute, 159. This. Yeah, we get 1.39 or approximately we can receive. Oh wait, sorry. This was supposed to be 4.3. Sorry. So 4.3, then we get 1.56. So we can approximately write 1.6 10 to the power of 11 pascals, right? So this is your Young modulus. Is there any problem from this question 18b2?
No, miss.
Okay, then if we move on to part 3, it says the experiment was repeated by another student using a 2-meter length of the copper wire. This time the length was 3.5 and then the second method was used, or the second student used 2-meter length. Suggest how the values obtained from the gradient and hence the Young modulus will differ for the students. You have to understand that strain is delta x over L, right? From there, you understand that L multiplied with strain delta x. If I'm using the same material, then strain is constant. For a smaller length, I'm supposed to get smaller extension. Okay, so for a smaller extension, mass over delta x. For a smaller extension, this entire fraction will be what? If the denominator decreases, like if the numerator is 1, if the denominator decreases, the total gradient will be greater actually, right? You have to understand this. 1 by 5 is 0.2, but 1 by 2 is 0.5. When the gradient decreases, the total fraction kind of increases. So you have to understand that for a smaller extension, the gradient will become large, right? This is your gradient. For a smaller extension, gradient will increase. And now again for the equation for your Young modulus, how will it affect Young modulus? It was force, length, area, extension, right? Over here, for a smaller extension, Young modulus will also increase because they are also inversely proportional, right? Oh, wait 1 minute. But then again, there's not only extension decreases, right? If extension decreases, length also increases. I mean, length also decreases over here. Over here, extension decreases, length also decreases. So basically, the change in your Young modulus is kind of cancelled out. So that's why Young modulus will remain the same. Only the gradient for your mass extension will be greater now. Is this clear? You're supposed to write it in this way that length and extension are directly proportional. So for a smaller length, you will get a smaller extension. smaller extension. Therefore, greater, but the strain remains same, right? I mean, over here for different length, different extension, the strain of the material will remain same. If strain is same, Young modulus will remain same, but it does not change the strain. So Young modulus remain the same. Right, you just have to write down the description and not of all these workings are supposed to be written. Is there any problem from this question 18?
No, miss.
Okay, then we are moving on to the last question. Over here, the student used the apparatus shown to investigate the forces acting on a uniform solid sphere placed in water. Draw free body diagram on the sphere as it is suspended in water as shown. Over here, the object is at rest, right? If the object is at rest, that means obviously what? All the forces are balanced here. This time, not only weight and upthrust is there, is in this situation is obviously the object is not in motion. That means drag is zero, but there will be a tension, right? Tension will be in the upward direction because the weight of the ball is pulling the string downward, but the tension is preventing the string from snapping. So there's upward force of tension. So you have equal upward and downward forces on this ball. In the downward direction, you have weight, and in the upward direction, you have tension plus upthrust, right? This is the case. Now, after this, it says that as the sphere was lowered into the water, the reading on the balance increased from 315 gram to 465 gram. Okay, then after this, explain the increase on the reading of the balance. Your answer should include reference to Newton's third law, right? In this case, what happens? At this point, you only have the mass of your water, right? This is 315 gram. So, I mean, over here, there's only mass of the water, but now when you are when you are submerging that, like, what is this? Submerging this, what is this? Ball, right? Ball into the water body. Obviously, the water body exerts an upward force, which is thrust, right? Up thrust, right? So, water body exerts an upward force, but obviously, the ball is not just going to stay there, right? I mean, over here, the upthrust I wrote obviously because I was trying to find out the forces acting on the ball, right? But since the ball is receiving this U Newton of force, upthrust force from the water body, according to Newton's third law, the ball will also exert the same amount of magnitude of force onto the water body. So there is a force extra acting onto the water body now. Previously, there was no force acting on the water body other than the mass of the water. That's why we got it as 0.315 gram or 0.315 kg. This time, because of the response of the upthrust, which was exerted by the water on the ball will also exert an equal and opposite force on the water body. That eventually increases the total weight on the reading over here. Is this clear?
Yes, miss.
Yes, ma'am.
So we can write that as the ball was submerged, the water exerts an upward upthrust on ball according to Newton's third law. The ball also exerts equal and opposite force on water in the downward direction, um, which increases the reading on the balance. On the balance. Okay. Now after this, for your 19 part B2, they're asking to determine the mass of the sphere, density of water, and density of sphere is given. Okay. Okay. Density of water is given 1000 and density of sphere is given. But we want to find out the mass of the water, right? Okay. I have to consider that, increase in the weight of water is actually the upthrust on the ball, right? I understand that. So upthrust on ball is equals to increase or a change in weight. I can understand. So upthrust of ball can be can be represented as density Vg rho Vg is equals to weight was how much? 0.465 minus 0.35 or 315, right? This was the case. In this case, for rho Vg, what is your rho? Rho is the density of the water because the ball was submerged inside the water. V is the volume of the water displaced, and or also you can consider that since the entire sphere was submerged inside the water, so volume of the water displaced or volume of the sphere is equal. So V we can consider as volume of the water, volume of the sphere, and G is 9.81. Right. So from there, I can write V is 0.465, 0.315 divided by your rho was how much? Density of the water was 1000 as the sphere was inserted into the water body. So we're talking about density of the water, and then again multiplied with 9.81. Right. So from there you get 0.465, 0.315 is 1000 multiplied with 9.81. That gives you 1.53 into 10 to the power of minus 5. 1 minute. 0.465. This was in kg me. 0.46535.
Means 0.465 and 0.315 are masses of water and ball
Right.
respectively.
In case we're supposed to multiply g with that also, right? So
Yes.
g cancels out. Right. So let's write g over here. G cancels out, and that means you're just left with 0.15 with 1000. That will be 1.5 into 10 power minus 4 meter cube. Right, this is the volume. Now, mass of the sphere can be calculated using this volume of sphere equals to, sorry, it will be, if I'm using the density equation, mass divided by volume. So mass will be volume multiplied with density of the sphere, right? So mass of sphere is just going to be volume with density of sphere. This time, by the way, I was referring to the density of water. So that's why over here you have 1.5 10 to the power of minus 4 multiplied with 2000. So zeros cancels out. You're left out with 0.3 kg. Right? This is the mass of the sphere. I hope the calculation was clear for everyone. Any problem from this B part 2?
No.
Okay, then
No, it's
Okay, then for the last question, actually, water is replaced with the same mass of oil, and the experiment is repeated. The density of the oil is less than the density of the water. Explain what happens to the final reading on the balance. This time, they're saying the density of the water or density of the oil is less than density of the water. If that is the case, then you have to consider that volume was what? Change in weight divided by, or rho Vg is equals to mg, but g and g cancels out. You have to understand that whatever the volume will be displaced in water and oil, that is also constant, right? So If this is the case, if this is a constant case, right? In that case, for a smaller density, the change in mass is also going to be small, right? I mean, over here, the reading on the balance will be less. I mean, in this case, the reading changed by 0.15 kg, but this time the reading would be like, changing less than that value. So you have to say that, upthrust, I mean, you have to say that, density of oil is less. Because of that, upthrust in oil is also going to be less. So the weight displaced is going to be less eventually. Therefore, the change in the balance, change in the reading on the balance is going to be less than that of water. So this is your only explanation here. So you can just write that for smaller density, less upthrust, and therefore the increasing balance reading is less than water. Is less than water, right? Now this was the end for your January 2020 entire paper. That means we have completed June 20, Jan 20, and you guys have to complete January 21 and June 21. Okay, by today. That means by entire Tuesday, you have to complete Jan 21 and June 21 and send me the papers by tomorrow night. Okay, by tomorrow night, 11 p.m. at least. Is that clear for everyone?